Okay, today's video is all about probability tree diagrams. So if you have a look at this one, the probability that I have chips on any day of the week is 0.4. Draw a tree diagram to show this for Monday and Tuesday. Find the probability that I have chips on both days. Find the probability that I have them at least once. You've got 3 questions there. So the first one we're going to have a look at is this thing here. Draw a tree diagram to show this for Monday and Tuesday. So on Monday, I've either got a choice. I can have chips or I can not have chips. So the probability that I have chips is 0.4. Now with tree diagrams, both these branches have to add up to one whole one, so that one's going to be 0.6. Then on Tuesday, that's Monday done. And on Tuesday, I can either have chips or not chips. Chips or not chips. Now for this one, this eventuality here means I had chips on Monday and chips on Tuesday. This eventuality here is I had chips on Monday and I didn't have chips on Tuesday. So I've had chips once on this one here and twice on this one here. So now what we've got to do is we've got to finish off the tree diagram by putting in the remaining probabilities. So probability I have chips is 0.4. Probability I don't have chips is 0.6. That's exactly the same down here. So 0.4 and 0.6. Remember, the ones down here just mean that I didn't have chips on Monday, but I have had chips on Tuesday. I haven't had chips on Monday, and I haven't had chips on Tuesday. So now what we've got to do is find the probability that I've had chips on both days. So what we've got to do is we've got to find that eventuality. So that is the top one here. And that's because I had chips on the Monday, so I've gone down that road, and I've had chips on the Tuesday, so I've gone down that road, which leads me to here. Now, with tree diagrams, the way you work out the probabilities at the end is you multiply the numbers together. So it's going to be 0.4 times by 0.4. And I don't mind if you use a calculator for this one. 4 times 4 is 16. There's 2 decimal places. There must be 2 decimal places there. That's going to be 0.16. So the probability here is 0.16. Now question C is always the one that catches people out. Find the probability that I have them at least once. So what we've got to do is we've got to go down and we've got to see which eventualities means that I've had chips at least once. And again, it's this word, or this term, at least. So here, I've had chips twice, so that is at least once. This one here means I had chips on the Monday, but I didn't have chips on the Tuesday, but I have had chips once, so we're going to include that one. This one here means that I didn't have chips on the Monday, but I have had chips on the Tuesday, which means I have had them once, so we're going to include that one. This one down the bottom here means I didn't have chips on Monday, didn't have chips on Tuesday, which means I haven't had them at least once on this eventuality down here. So I've got to work out this probability, and this probability, and then I add them all together. So as we said beforehand, there's 0.4 times 0.4. So this one is 0.16. This eventuality here is 0.4 times 0.6, which is 0.24. Again, I don't mind if you use a calculator. It's the method that we're looking at more than anything here. This eventuality here, I used this one here, which is 0.6, and then this road here, which is 0.4. So 0.6 times by 0.4, which is 0.24. Then you can add them together. So 0.16 plus 0.24 is 0.4, and then plus this one is 0.64. So that is a probability that I've had chips at least once. Now, your turn. I'm going to give you a second just to pause the video, and let's go through it. So the probability that I hit a good golf shot is 0.7. So draw a tree diagram for the 2 shots. So I can either hit a good shot or a bad shot. In shot 2, I can either hit a good shot or a bad shot. So the probability that I hit a good golf shot, which isn't accurate for me, is 0.7. Probability that I hit a bad golf shot is 0.3. So good golf shot is 0.7, bad is 0.3, 0.7, 0.3. Now what I've got to do is find the probability that I don't hit a good golf shot. So if I don't hit a good golf shot, this one here, I've hit 2 good golf shots. This one here, so I don't want that one, sorry. This one here, I hit 1 good golf shot first of all, and then I hit a bad shot. This one here, I hit a bad shot first of all, and then I hit a good shot. This one down here means I hit a bad shot, and then I hit a bad shot. So this is the one I want. I don't hit a good shot. So that's going to be 0.3 times by 0.3, which equals 0.09. So that's the probability for this one, 0.09. Well done if you got that one. Part C, find the probability that I hit exactly 1 good shot. Now again, exactly 1 good shot. So let's have a look at what we've got here. And the first one, I hit 2 good golf shots, so we don't want that one. This one here, I hit 1 good, then 1 bad, so I do want that one because that is exactly 1 good golf shot. This one here, I hit a bad one first of all, then a good one, so that is 1 good golf shot. This one down here, I've hit no good golf shots, so that's 2 bad shots, so I don't want that one. So I just want this one here and this one here. So that's going to be 0.7 times 0.3, which equals 0.21. This one here is 0.3 times by 0.7, which equals 0.21. I then add them together, which is 0.42. Well done if you got that one.